Hey guys, we're going to do notes today over trig functions of any angle. So I want you to remember on a unit circle, basically you have this reference angle right here, theta. This part right here is always drawn from that point on the unit circle perpendicular to the closest x-axis. We talked about how this would be the y-coordinate of this ordered pair right here. This would be the x value, and this is your radius. And so remember, sine is the opposite over hypotenuse, and so that's why it ends up being y over r. Cosine is the adjacent over hypotenuse, so that's why it ends up being x over r. Tangent is opposite over adjacent, so it would be y over x. Cotangent is the reciprocal of tangent, so it's going to be adjacent over opposite, which is why it's x over y. Secant is a reciprocal of cosine, so it's going to be adjacent over, that's backwards. Secant is reciprocal of cosine, so it's hypotenuse over adjacent. Sorry about that. And then cosecant is reciprocal of sine, so it's hypotenuse over opposite. All right, so let's do an example. Okay, for this first example, we have the point -3, 4. So I'm going to draw -3, 4, which would be about right here. That's a point on the terminal side of theta. So remember, when we draw an angle, this would be our initial side here. This would be our terminal side that goes through that point. So this is the theta they're talking about. The reference angle is always formed by the terminal side right here and the closest x-axis, and then you draw a line perpendicular to that x-axis. So we already know that this part right here is -3. We know this part's 4. We can use Pythagorean theorem and say a squared plus -3 squared. Oh, I'm sorry. Let me go back. We would say -3 squared plus 4 squared equals c squared, and you end up getting c equals 5 for this hypotenuse right here. It's a 3, 4, 5 triangle. All right, then they're asking us to figure out what the sine of theta is. So sine of theta would be y over r. So in this case, it would be 4/5. Cosine of theta would be x over r, or adjacent over hypotenuse, and it's -3/5. And then tangent of theta equals y over x, so it's going to be 4 over -3. So those are those three trig functions, knowing that -3, 4 goes through the terminal side of that angle. Okay, so another example, it's the one below. This time, sine of theta is a -2/3. Well, if you'll recall, the sine of theta is y over x, and so it's going to be positive wherever the y's are positive, which are, this is where sine is positive. It's positive here and it's positive here. Sine is going to be negative in these two quadrants, and that's because that's where the y values are negative. So I accidentally just noticed, that I put y over x for sine. This should have been y over r. Sorry about that. So again, sine, though, is positive because in quadrants 1 and 2, because that's where the y's are positive, and sine is negative where the y values are negative. So we learned that acronym. All students take calculus. It's telling me that the sine is always going to be positive in the first quadrant and second quadrant, but it's negative in the third and fourth quadrant. So because sine is negative, I know I'm going to either be in this quadrant or this quadrant. So think about that when we're trying to figure out which quadrant to draw our triangle in. Tangent is positive in, let's change pen colors. Tangent's positive in this quadrant and this quadrant. So the quadrant that matches for both of those, since this one is quadrant 1 and quadrant 3, the quadrant that matches both of those criteria would be quadrant 4. So that's where I'm going to be drawing my triangle, in quadrant 4. Again, you make the perpendicular side with the closest x-axis. This is your reference angle right here. This is your theta. You're told that sine is -2/3, so the y value will be -2. The hypotenuse will be 3. So now you need to do Pythagorean theorem to figure out what the x value is. So we'll do -2 squared plus b squared equals 3 squared. That gives me b squared equals 5. So b equals the square root of 5. Really, it equals plus or minus the square root of 5. But because we're in this quadrant, the x value will be negative here, so that will be negative square root of 5. So now when they ask me for the cosine of that theta will be the x over the r. So it'll be negative square root of 5 over 3. And then tangent of the, or I'm sorry, they want cotangent of the, cotangent of theta is x over y. So it's going to be a negative square root of 5 over a negative 2, which simplifies to be square root of 5 over 2. Okay. All right, on this example, I want you to remember that this is 0, this is pi over 2, this is pi, this is 3 pi over 2. And then recall that on the unit circle, at 0 we have the ordered pair 1, 0, because our radius is 1. At pi over 2, it's 0, 1. At pi, it's negative 1, 0. And at 3 pi over 2, it's 0, negative 1. Okay, so remember they're asking us here for the sine and cosine of each of those. So we're going to do the sine of 0, the sine of pi over 2, sine of pi, and sine of 3 pi over 2. Remember we talked about on the unit circle we have an ordered pair for each of all around the circle we have an ordered pair. The x value is the cosine and the y value is the sine. And it's the unit circle. It's because the radius is always 1. So when you do cosine is x over r, the radius is 1. So that's why it's always just whatever the x value is. So sine is the y value. So at 0, the y value is 0. So will be 0. At pi over 2, the y value is 1. So the sine of pi over 2 is 1. The sine of pi, you look at that y value, it's 0. And then at 3 pi over 2, I'll look at that y value, and it's negative 1. And then I'm going to do the same thing for the cosine. So cosine of 0 is 1 because the x value is 1. Cosine of pi over 2 is 0, and that's because the x value is 0. Cosine of pi equals negative 1. And then cosine of 3 pi over 2 equals 0. All right, the next set of examples, they're just wanting you to remember how to use your unit circle, basically. Remember 4 pi over 3. This is pi right here, which is 3 pi over 3 to get a common denominator. So 4 pi over 3 is going to be in the third quadrant. So that represents 4 pi over 3. Any pi over 3 is a 60-degree reference angle. So this would be a negative square root of 3 across from that 60 degrees. This would be negative 1, and this would be 2. Cosine is adjacent over hypotenuse, so it's a negative 1/2. Or if you have your unit circle memorized, over here where our 60-degree reference angle is, that's the ordered pair 1/2 square root of 3 over 2. So it's the x value on the unit circle. And then remember that you're in this quadrant, and cosine would be negative in that quadrant. So cosine of 4 pi over 3 is a negative 1/2. Tangent of 210 degrees, I have to go in the clockwise direction because it's negative. So I'm going to start here. I'm going to go around. This is negative 180. Another 30 degrees past that would be 210. So my reference angle is 30. So I'm using a 30, 60, 90 triangle. The side across from 30 is 1. The side across from 60 is square root of 3. It's negative in this quadrant. And then this is 2. Tangent is y over x. So it's going to be 1 over a negative square root of 3. If you rationalized it, it would be negative square root of 3 over 3. All right, 11 pi over 4. This is 1 pi over 4, 2, 3, 4 pi over 4, 5 pi over 4, 6 pi over 4, 7 pi over 4, 8 pi over 4. So here we're at 8 pi over 4, and then this is 9 pi over 4, 10 pi over 4. So this right here would be our 11 pi over 4. And then 11 pi over 4, which is right there, any pi over 4 is a 45-degree reference angle. So we'll use 1, 1. The x is negative there. And this is square root of 2. So I'm using my 45, 45, 90 rules. cosecant's the reciprocal of sine, so it's going to be r over y, which would be the square root of 2 over 1. So it's just square root of 2. Okay, so for these, they're just using those rules. So we would know like sine of 45 degree angle using those rules. This is 1 square root of 2. Sine of 45 is, when you simplify it, you know, it's going to be 1 over square root of 2, but it ends up being square root of 2 over 2 when you rationalize it. Tangent's just 1, so, and then this is telling us to multiply those together, so my answer is going to be square root of 2 over 2. On this next one, we've got pi over 3, which is a 60-degree reference angle. This is square root of 3, this is 1, and this is 2. So the sine is square root of 3 over 2, and you're going to add to it the cosine of pi over 6. Well, pi over 6 is a 30-degree reference angle, and the cosine would be square root of 3 over 2. When you add those together, remember this has a coefficient of 1 and 1, so you'll get 2 square root of 3 over 2. The 2's cancel, so your answer is just square root of 3. On the next one, we've got cosine of 60. So the cosine would be 1/2. And then the sine of 135. Sine of 135 is over here. It's a 45-degree reference angle. And the sine would end up being square root of 2 over 2 there. And when you multiply straight across. So 1 times square root of 2 is square root of 2, and 2 times 2 is 4. So this would be my answer for that. On this one, you're going to take 2 and you're going to multiply it by sine of 5 pi over 3. Well, 5 pi over 3 is over here with a 60-degree reference angle. It's negative there. Sine is going to be a negative square root of 3 over 2 minus 6, and then you're going to do cotangent of pi over 2. Pi over 2 is up here. That's an ordered pair of 0, 1. Cotangent does x over y, so it'll be 0 over 1. So that'll end up being a negative square root of 3 minus 0, which is just negative square root of 3. And that's your answer. On H, we've got 7 pi over 6. This is pi, which is 6 pi over 6. So 7 pi over 6 is down here. It's a 30-degree reference angle. This is a negative 1, negative square root of 3, and 2. Tangent is y over x. So we'll do a negative 1 over square root of 3. Rationalize it by multiplying by the square root of 3 over square root of 3. So you get negative square root of 3 over 3. Secant of 5 pi over 6. 5 pi over 6 will be right here if this is 6 pi over 6. 30-degree reference angle, so 1 square root of 3 and 2. Secant is the reciprocal of cosine, so it'll be r over x. So it'll be 2 over a negative square root of 3. You should technically rationalize it, so you'll multiply it by square root of 3 over square root of 3 to get 2 square root of 3 over 3, and it's negative. Okay, on this one, they tell me I have to be in quadrant 2. So I'm going to draw my triangle in that quadrant. They're also telling me sine is 1 over 3. Remember, sine is y over r, so I'll put the 1 where the y is and 3 where the r is. I've got to figure out the x side so that I can do cosine, because cosine is x over r. So I'll do 1 squared plus b squared equals 3 squared. That gives me b squared equals 8. So b equals the square root of 8. So I'm going to just keep it that way. You could write it as 2 square root of 2, but I'm going to keep it square root of 8. And then that's negative in that quadrant. So cosine would be a negative square root of 8 over 3. If you kept it simplified, it would be negative 2 square root of 2 over 3. All right, on this one, they want you to name what quadrant you would end up in. So I'm going to remind you that all of them are positive here. Sine and cosecant are positive here. Tangent and cotangent are positive here. And cosine and secant are positive here. So I know that secant is negative wherever cosine is negative, so that'll be here and here. So that's quadrant 2 and quadrant 3. Tangent, on the other hand, is positive in the first quadrant and the third quadrant. So quadrant 1 and quadrant 3. So where where the quadrant that meets both criteria would be quadrant 3. So we would say the answer here is quadrant 3. All right, last example. I'm going to choose the quadrant where the tangent is positive. Tangent's positive in the first quadrant and the third quadrant, so quadrant 1 and quadrant 3. I also know cosine is negative. It's going to be negative in quadrant 2 and quadrant 3. So the quadrant that meets both criteria is quadrant 3, so that's where I'm going to draw my triangle. I know tangent is 3 over 4, and tangent is y over x, so we're going to put the 3 here and the 4 here. Now, because we're in this quadrant, the y's have to be negative and the x's have to be negative. And so technically, it was negative 3 over negative 4, but your negatives canceled out to get that positive 3/4. If I did the Pythagorean theorem, I would find out that the hypotenuse is 5. It's a 3, 4, 5 triangle. And then I'm going to do the sine of that angle. So sine is y over r, so it's going to be a negative 3/5. And that's my answer. All right, thanks, y'all.